Good day, grade 10 students. Welcome again to another fun and exciting mathematics lesson. And I'm teacher Darwin, and I'll be your guide for today's lesson. Okay students, before we start, I will be giving you a game that I will be calling as the word search game. And for this task, you are given 5 words and you need to find that on the given random letters that I'll be showing in the screen. The words that you need to find are the probability, possible, likely, chance, and the outcome. Okay, you are given 5 words to find in our random letters. In this activity, I'll be giving you 2 minutes to find the 5 words on the given screen. Okay, very good students. We found out the 5 words on the given random letters. So first, we have the probability. Second, we have the possible. Third, likely. Fourth, chance. And fifth one is outcome. Very good, students. Okay, and now students, that on that activity you found out the word probability and some words related to it. And I also know that we already done discussing about the probability of simple events. And for our lesson for today, it is just a continuation of this topic. Okay students, so for today's lesson, we will be discussing about the mutually exclusive events and non-mutually exclusive events. Okay, so let's start with mutually exclusive events. So these are events that do not have the same elements, or these are events that cannot happen at the same time. For example, in rolling a die, it is expected that we only have one outcome. So it can happen that the outcome would be 1 and 2. So we only have one outcome. Or in real life, you cannot drink water at the same time eating food. So that is example of mutually exclusive events. Okay, so in solving the probability of mutually exclusive events, we have the formula here. So probability of the quantity of A or B, that is equal to probability of A plus probability of B. Okay, so the keyword for these mutually exclusive events is the conjunction OR. Okay students, let's have the example for the probability of mutually exclusive events. A card is drawn at random from a standard deck of cards. What is the probability of drawing a king or a queen? Remember, our keyword for that is the word OR for the probability of mutually exclusive events. And remember that in a standard deck of cards, we have 52 cards on that. Specifically, 13 diamond cards, 13 heart cards, 13 spade cards, and 13 club cards. Okay students, so we are going to use the formula for the probability of mutually exclusive events. Specifically, the probability of A or B, or that is the event A and the event B, and that is equal to probability of A plus probability of B. Applying the formula, we just need to interchange A for king and then B for queen. So the probability of king or queen, and that is equal to probability of king and then probability of queen, or plus the probability of queen. So on that problem, remember that in a standard deck of cards, we have 4 kings. So that is 4 out of 52. The probability of drawing a king is 4 out of 52. While the probability of drawing a queen is also 4 out of 52. So we just need to add those two fractions. So we have 4 over 52 plus 4 over 52, and that is equal to 8 over 52, or by simplifying that, you'll have 2 over 13. Your answer can be fraction, or it can also be decimal. So for our first example, the answer is 2 over 13. Okay students, another example for the probability of mutually exclusive events. A box contains 5 blue balls, 4 red balls, and 3 yellow balls. Diane throws 1 ball at random. What is the probability that the ball is either blue or red? Okay, so we just need to focus on the blue or the red balls. For our solution, again, we use the formula for the probability of mutually exclusive events, which is probability of A or B, and that is equal to probability of A plus probability of B. In combination with that, we just need to change A as blue and then B as red. So probability of blue or red, and that is equal to probability of blue and then probability of red. On that problem, all in all, we have 12 balls. 5 blue balls, 4 red balls, and then 3 yellow balls. So we have 12 balls in total. So the probability of getting blue on that problem is actually 5 out of 12, because we have 5 blue balls out of the 12 balls, all in all. Plus, the probability of red balls, we have 4 over 12. Why? Because we have 4 red balls out of the 12 balls. So we just again need to add those two fractions to get our answer. So 5 over 12 plus 4 over 12, that is equal to 9 over 12. And by simplifying that, we'll have 3 over 4. Or on decimal, we can convert that as 0.75. And that's all for the examples on the mutually exclusive events, or the probability of mutually exclusive events. Okay, let's proceed with non-mutually exclusive events or mutually inclusive events. So these are events that have outcomes in common, or they have common elements. For example, throwing a card in a standard deck of cards with a heart and at the same time a red. So they have in common a red, at the same time it is a heart. Okay, so for our formula on non-mutually exclusive events, we use probability of A or B, that is equal to probability of A plus probability of B minus probability of A intersection B. So if you are thinking what is the probability of A intersection B, it is the probability of the events where they have common, or on the events that they have in common. Okay, students, so on the part that we subtracted probability of A intersection B, it is the probability of the events where they have common elements. So for example, for the probability of non-mutually exclusive events, a card is drawn at a random from standard deck of cards. What is the probability of drawing a king or a black card? So on this problem, on the probability of non-mutually exclusive events, we have the formula probability of A or B, and that is equal to probability of A plus probability of B minus the probability of A intersection B. So again, for the event A and B, for A, we have the probability of a king, and then for B, the probability that the card is a black. So probability of king or black is equal to probability of king plus probability of black minus the probability of king intersection black. Okay, by applying the formula, we have the probability of king. So on the standard deck of cards, we have 4 kings. So that is 4 out of 52. Plus, on the standard deck of cards, we exactly have 26 black cards. So that is 26 out of 52. Minus the intersection, probability of a king intersection black. So how many cards is a king at the same time a black card? So we have 2. The king of spade and the king of clubs. So we have 2 out of 52. So that is their intersection. So simplifying that, you will have 28 over 52 or 7 over 30. So that is the probability for the problem number 1. The answer is 7 over 30. Okay students, let's have another example for the probability of non-mutually exclusive events. Die is rolled. What is the probability of getting a 1 or an odd number? Okay, so let's proceed with our solution. Probability of A or B is equal to probability of A plus probability of B minus the probability of A intersection B as our formula. So again, for event A, we change that as 1, and then B for add. So we have probability of 1 or add, and that is equal to probability of 1 plus probability of add minus the probability of 1 intersection add. So on the probability of getting a 1 on a die, we have 1 out of 6 as its probability. And then for add, we have 3 adds on a given die. So that is 1, 3, and 5. So we have 3 out of 6 minus the probability of 1 intersection add. So we only have 1 as our add on that part, so 1 out of 6. So simplifying that, we'll have 3 over 6, or we'll have 1 over 2, or on decimal, we'll get 0.5 or 0.50 as our solution. Okay students, that's all for our examples on the probability of mutually exclusive events and non-mutually exclusive events. Again, remember the difference between the mutually exclusive events and non-mutually exclusive events. Wherein, in mutually exclusive events, these are events that cannot happen at the same time. Just like tossing a coin. You cannot get a head at the same time, a tail, on tossing a coin. While in the non-mutually exclusive events, these are events that have a common elements, like in drawing a card that is an ace at the same time a red card. So we have 2 red aces cards, so that is their common part for the non-mutually exclusive events. Okay students, after the discussion, let's proceed now with your practice exercise. And I will be showing you on the screen your exercise. And I'll be giving 5 minutes for you to answer those problems. For your assignment, again, please refer on the screen, write all the problems, and let's check that on the next meeting.